Good, af- Good morning, everyone. My topic is magnetic and dynamic studies on sputter-deposited FeAl alloy thin film conducting flexible copper substrate. This work is done under the supervision of Professor Manoj Kumar, Department of Electronic Science, and Professor Vijay Kumar, Special Center for Nanoscience. Basically, we are working on flexible substrate, and flexible materials are very useful in semiconductor and all the industries. This technology enhances device versatility and because of bending, folding, and making different shape and size of the devices. These films offer numerous advantages over rigid electronics, and they are easily foldable. We can roll it, we can print anything on this. So we are working on flexible substrate. And we have chosen the compound FeAl, iron aluminum alloy. Iron aluminum basically it's at a particular composition or range of composition. It works as a magnetostrictive material. Magnetostrictive material are basically materials on which their property change with the applying the stress or strain. So we are working on FeAl alloy compounds. It's 11 to 16% of Fe with 11 to 16% of aluminum with Fe make them as a magnetostrictive material. So we are working on this. We have fabricated the FeAl through POS sputtering, on which this is our system on which we have deposited through POS sputtering, and in which and the power of the aluminum gun was fixed, and the power of iron gun power of iron gun vary the composition of FeAl. We have basically made three compositions: Fe65, Al35, Fe70, and Al30, and Fe75, Al25. The deposition temperature was 250 degrees Celsius, and the chamber pressure was 5 into 10⁻⁻7 torr. Argon pressure was 2.5 millitorr. The targets used for this was from the sigma entry, and the thickness of the thickness was maintained at 50 nanometer using the thickness monitor. This is the instruments which we have used for the characterization. The XRD used from our center also, or AFM, for making the roughness of the film. This is our homemade system of VSM. We use this for measuring the dynamic characteristics of the film, and this is the VSM setup that is used for measuring the static characteristics of the thin film. This is basically the XRD, in which if you find that there is this is the XRD copper tape substrate I have used as a flexible substrate, and this is the XRD of copper tape. But when we deposited FeAl, you will find that with the increase in the iron concentration, the peak at 44.4 increases, and this peak shows that the A2 phase of the film, and it also confirms that the FeAl is deposited, and we get the A2 phase. This is the AFM image of the film which we have deposited. The AFM image shows that, and the value shows that with increase in iron concentration, the roughness decreases. This is basically shows the static characteristics, in which we find that the corrosivity decreases with increase in iron concentration, and this is because of the enhancement in alignment of the magnetic domain of the deposited thin film. This is the dynamic characteristics we have measured using the vector network analyzer, and when we plotted it and fitted it with LLG equation, we find that the Gilbert damping decreases with increase in the iron concentration. This is because of the with increase in the iron concentration, the structural defect decreases, magnetic ordering increases. This is basically the present. This basically gives you gives the data of the magnetization. Using the Kittel equation, we fitted the HR versus frequency, and we find that the magnetization increases from 14.44 kiloastat to 16.57 kiloastat at increase in the iron concentration. This is the summary of the result, in which as the composition is 65-35, MS is 44.44, SC is 44, and Gilbert damping is 16.96, and roughness is 0.86 nanometer. Similarly, with increase in the iron concentration and with the MS increases, as well as Gilbert damping also increases and roughness decreases. The conclusion is that we have fabricated a FeAl thin film with A2 phase. Roughness decreases, corrosivity also decreases with increase in iron concentration. And from this graph, we can show that it is approximately fitted curve, which shows that the homogeneity in the thin film. Yeah, homogeneity in the thin film. And we can use this flexible substrate to improve in medical technology, space technology, and all main the research going on in enhancing the functionality using FeAl and all that compounds. Basically, these are the some advantages. We can use it as a flexible substrate, and there is a magnetostatic properties of FeAl that can be used in device fabrication and many more places. Thank you.
Ma'am, I think you are muted.
Sorry. Thank you for the presentation, Prashant. So now the floor is open for the questions. So, yeah. Okay. So basically you have, so what is the actual application you can do from your material, like your reach? What is the, so can you do it yourself, or it is like you just studied the structural part and magnetic?
Currently we are studying the structural part and properties. We can apply the stress and the strain, and we are measuring that also. We have made some setup for measuring that stress or strain part also. For flexible, we can basically band it, or we can apply compress it. So there is a change in the saturation and all the properties of the material. So we are working on that, and currently we are making some measurement for this. And the main aim is to use the basically the substrate which are available in flexible substrate are costly. So we are using some basic materials as a flexible substrate, like Teflon tape, copper tape, mica sheet. These are not costly. So we are working on that only.
Okay. Okay. Thank you so much for your time.